Sequences. Explicit formulas for arithmetic sequences. Find the explicit formula for the arithmetic sequence. So you have negative 11, that's your first term. Your second term is negative 3. Your third term is 5. And your fourth term is 13. So the first term we start with is negative 11. So that's important. So that's going to be the first number we start with will be negative 11. Now we want to figure out how far are we between the next number. What rule are we using here? So we want to identify the rule. It can be a positive number. It can be a negative number. Well, a negative 11, negative 3 might not be too obvious. Negative 3, negative 5 might not be too obvious. But 5 to 13 is obvious. That's a plus 8. So let's go back and check this. A negative 11 plus 8. So negative 11 plus 8 would be negative 3. Let's take a negative 3 plus 8. So negative 3 plus 8 is a positive 5. So our rule here is positive 8. So we got negative 11. That's our first number in the sequence. Our rule is plus 8. And then we want to finish up with the n minus 1 in parentheses. So that's how we assemble it together. Remember, you'll always end with the n minus 1. So we're going to say negative 11 plus 8. So we're going to have plus 8. Now we're going to begin our parentheses. So we're going to say n minus 1. Kostofo and Yukai were asked to find explicit formula for the sequence 19, 0, negative 19, and negative 38. So we want to figure out which student is correct. So this is our first, this is our second, this is our third, and this is our fourth. Remember, we're finding the explicit. So the very first number in our sequence would be 19. Now to go from 19 to 0, 0 to negative 19, negative 19, negative 38. Notice we're ending with a negative number, so our rule is going to be negative. Well, this is pretty obvious because to go from 19 to 0 has got to be a negative 19. To go from 0 to negative 19 again is a negative 19. To go from negative 19 to negative 38 is a negative 19. So our rule is negative 19 here. So you would say negative 19 followed by the n minus 1. So our rule would be 19 minus 19, and then we would have n minus 1. Now that really doesn't match there, so let's do this. Let's go ahead and distribute by the negative 19. So we'd have 19, let me write this better. So we would have 19 here. This would become a negative 19n. And then a negative 19 times a negative 1 would be a positive 19. So let's assemble this together. So you would have a negative 19n, but we would have a positive 19, and we would have also a positive 19 again, and that would be a positive 38. So that really doesn't match any of them, so neither would be correct. Find the explicit formula for the arithmetic sequence. So we have negative 31, that's our first term. Then we have our second term, our third term, and our fourth term. So the first term is a negative 31. Now we want to figure out what our rule is. From a negative 31 to a negative 27. Well, if you notice here that this right here is the smaller, this is the larger. Yes, they're both negative, but they're going in a larger direction. So what we're doing is we're actually adding 4 here. Negative 31 plus 4 is a negative 27. Negative 27 plus 4 is a negative 23. Negative 23 plus 4 is a negative 19. And again, if you're confused by this, you could simply just forget your negatives and take negative 31 minus 27, and you would get 4. But since these numbers are negative, this would also become a negative. So that would actually be, that would be maintaining the negatives as we're going down the line here. So we got negative 31, negative 27, negative 23, negative 19. But again, if you're confused by these negatives, you can simply just say 31 minus 27 to get the 4. So we're saying our rule is going to be actually plus 4. So even though it's even though they're both negatives, we're not getting a negative there, we're getting a positive 4. And then we want to finish off with n minus 1. So right here, we come over here, we'll say negative 31 plus 4. Now we'll start our parentheses and we'll say n minus 1. And again, remember, don't get fooled by these negatives. You could take 27 minus 23, and that's 4. So again, even though we're negatives here, it still shows that it's a positive 4 there. And we could have done it for the last one, 23 minus 19, that's also equal to 4. Because I know a lot of people get intimidated by all these negatives here. So what you could do is simply write down the numbers without the negative sign and just subtract them as two positive, like a positive 31 subtract a 27, 27 subtract a positive 23, 23 subtracting a 19, and you can see you get the 4 each time. Okay, now we have again two students here, Irma and Uram and Aubrey. We're asked to find explicit formula for the sequence. So this is our first, this is our second, this is our third, and this is our fourth. Notice it's gotten smaller. It's went from a positive to a negative, so that's probably a good indication that it's going to be a negative number here. So our very first number in the sequence is 14. If we took 14 minus 5 like we did earlier in the other problem, we get actually 9. But we couldn't say a plus 9 here, because if you said a plus 9, 14 plus 9 makes 23. We want it to be 5. So since it's getting smaller from a positive to a negative, you have to treat it as a negative 9, not as a positive 9, because the numbers are getting smaller. So 14 minus 5, 14, actually scratch that, let's say 14 minus a negative 9. So 14 minus a negative 9 is 5. 5 minus 9, well, you owe $9, you get 5, you still owe 4, it's a negative 4. And then a negative 4 and a negative 9, well, 4 plus 9 is 13, and it's a double borrow, so it maintains a negative, it's also a negative 13. So we're going to have 14 minus 9, and then we're going to have n minus 1. So make sure you realize that yeah, even though we subtract, we got that positive 9 at the start, it's not, you're not adding 9 each time, you're actually subtracting by 9 because you want the numbers to get smaller. So looking at that, we actually exactly match the first student. Now what about the second student? Suppose we go ahead and multiply through here. So this student is good, but before we dismiss Aubrey, let's check this. Let's multiply here, let's distribute. So we get a minus 9n plus 9. So now we'll say negative 9n. We'll add now the 14 plus 9, which actually becomes 23. That still doesn't match Aubrey, so his is wrong. So it's only the first student here.